the only constant in software is change.
Welcome to the MongoDB podcast. This is the podcast where we talk about software development, data, and all things MongoDB. As always, I'm joined with my co-host, Nick Raboy. Hey, Nick, how's it going?
It's going great over here, Mike.
All right, we've got a good one today. So MongoDB's built-in aggregation framework is a powerful tool for performing analytics, statistical analysis, all in real time. And developers can use it, to generate powerful data queries and to do stuff against their database in real time. So in this episode, we're joined by Asya Kamsky from the Office of the CTO here at MongoDB. And she joins us to talk about the foundations of the aggregation framework and how it works and how you can use it like a pipeline of sorts. So if you're a data analyst or a developer looking to increase the power of your querying capabilities against MongoDB, this episode is for you.
Asya, how's it going? Thanks for tuning in to this particular podcast episode and being our guest. Do you want to start by introducing yourself?
Sure, why not? I may as well start by saying aggregation is my favorite feature of MongoDB. So don't thank me. I thank you for having me to talk about it. So I'm Asya Kamsky. I've been at MongoDB for 8 years. Holy cow, that's a record for me. But I've worked with databases pretty much from my almost entire career, and mostly obviously with relational databases until the whole NoSQL thing came around, and I was like, NoSQL, what's that? I know SQL. And then I tried MongoDB and I fell in love, and the rest was history. We've lived happily ever after.
So outside of MongoDB, you doing anything special? Any kind of personal interests?
Life outside of MongoDB. What's that like? I love to travel. Luckily, I get to do that as part of my job since, I get to go to a lot of conferences to talk about stuff, and I get to visit our customers and, figure out what's going not the best so I can pipe that feedback into engineering and product planning. And so I kind of get to do my favorite hobby of travel just kind of as part of my job, which is kind of one of the reasons I love my job.
That's great. I love your LinkedIn photo.
Has the one of me in the overhead?
In the overhead, yeah. That's phenomenal.
Overhead of what?
In a plane in the overhead compartment.
Yeah. Oh. Yeah, people asked me how I got in there, and I said, well, obviously the flight attendant had to give me a hand. You can't just do a pull-up into the area yourself. It was in a hangar, though, so I hope people don't, freak out about it or something like that.
Great. So I guess let's get into the technical portion. I'm a huge fan of the aggregation framework. I've always wondered why it seems like it's treated separately from the query language. It's almost like a subcomponent of. But maybe help the listeners that are new to the aggregation framework, and maybe if you could give a description of what this thing is in your own terms.
Yeah, when MongoDB was first created, being developed, right, the query language was like finds and updates, right? Because at the time it was kind of thought, well, you want to do point queries, right? Since the old mmap storage engine didn't give you any kind of a point in time guarantees, querying over many objects was, it was only okay if you were okay with kind of approximate view of the world, since that view of the world didn't have to be at a single fixed point, right? And so at some point it was like, well, wait a minute, we do need to have some kind of aggregation functionality, right, for things like, counts and group bys and the more complex sort of things. Mm-hmm. And there wasn't really a way to shoehorn it into the find semantic, since find was already defined as, you find something and you have some control over the shape of the document, right? The projection, just like SQL, you can ask just for the fields you need, but that's it, right? And for good or bad, I'm not really sure, because this was so long ago. It's a fuzzy point in the history of everything. Mm-hmm. Rather than trying to tack on more, modifiers or qualifiers, kind of like, sort by and skip and limit are kind of modifiers of find. We were like, well, we're going to need a whole bunch of different stages, right? Because as you're aggregating things, you might want to do more things to the documents, and then you might want to aggregate them again, right? So we wanted something declarative, but that had a very specific order, which find just didn't lend itself very well to being extended that way. So aggregate command showed up, and the aggregate command could take stages, right? And some of the stages were very obvious because they just got mapped from the find world, right? So the most obvious thing that everybody does first with an aggregation pipeline is they want to match just a subset of documents that they want to do the aggregation on, kind of like a find. And so the mechanism under the hood was always the same, right? Find gives you a cursor, so match at the beginning of an aggregation pipeline gives you a cursor. But at the end of that cursor, all the documents that you iterate, instead of returning them back to you, they get fed through a pipeline or a set of stages that do whatever transformations on those documents so that they can return only final result, whether that be a single result, a set of differently shaped documents, etc. I've given several talks on aggregation pipeline, and I kind of show it as a left to right transformation of documents as they flow through each stage. So the nice thing about that is it's conceptually it's really straightforward to visualize what happens to your documents as they flow through the pipeline and how they get transformed. And then, if you think about all the different stages as different ways to impact or transform the documents flowing through it, right? Like match is just like a find. It says, I only want the documents that match this, or I only want the documents that don't match this, right? And sort takes all the documents and just reshuffles their order, right? Limit, skip, etc. But then group takes the documents coming in and turns them into completely different documents, because you're telling it, I want to group by this field, and then I want to accumulate these other values, right? And you're defining completely exactly what kind of documents, what shape of documents you want.
So I have a few questions actually. So I know Mike had mentioned that it was the aggregation framework. I saw that you were using the term pipeline. What is it truly? Is it both a framework and a pipeline, or do you have a preference?
Initially we always said framework for whatever reason, because when I joined the company, it was in development. It was released in 2.2 in production. So I joined when we were early in the 2.0 time cycle, but obviously the decisions and the development work had already started. And that's what we called it, an aggregation framework. And then the more we talked about it, the more we realized we were constantly referencing it as, in the pipeline, in the pipeline. And it was more intuitive, I think, to think of it as the aggregation pipeline, right? Just like, you pipe a file to a bunch of commands on like Unix command line, right? grep and then sed, awk, whatever. Kind of the same thing here. So framework is a kind of a very generic term that to me doesn't say much about the aggregation, but pipeline tells me that, data flows through a pipeline and I get to control what stages are in the pipeline and what they do. Does that make sense?
Yeah, it does make sense.
I kind of thought of the pipeline as a feature of the framework. The framework has operators like $match and $sort, $group. Those are the operators. And then the feature of those things is that you can pipeline them together very much in the same way that you pipe the output of one command in Unix to the input of another, right?
Right. Yeah. So stages are like commands within, the pipeline. But then within stages, you get to use a very massive set of powerful expressions. We're discussing the hardest problem in computer science right now, right? Naming things. And also at MongoDB, we have a proud tradition of picking really poor names for so many things that, yeah, I'm just happy both of those terms aren't completely misleading about what the aggregation is.
So for somebody who's trying to get started with the aggregation pipeline, who maybe have only been exposed to find one kind of commands, are they going to have to look forward to learning a new kind of query language that MongoDB uses, or would you say that it's very comparable to the operators and the whole style that you would apply to the finds?
Well, one thing that we're trying to work towards is reducing the number of languages that you have to learn. For example, right now, in find you get a certain set of operators, and then in projection, there's obviously some common elements, but it's slightly different, smaller subset of operators. And then in update, right, the update is a query, which is same as find query, but then the mutation language of the update is its own language. And we've sort of been wanting to get everything to converge in a single language so that then people don't actually care about whether that language is called, the aggregation framework language or the find language or the, update language, that they'll just know here's a massive, powerful set of expressions that they can use in lots of different places. Does that
Hmm.
make sense?
Yeah, it does. So it might help if we describe the aggregation framework in terms, well, in syntactic terms. If you're executing a command at the MongoDB query language or via a driver, you're going to leverage the syntax. You're going to say DB, which is reserved, dot, and the name of the collection that you're
Yep.
working. And then you're going to either issue an operator like find, so db.collection.find, or you're going to invoke the aggregation framework. And that's where you get to unpack all of this awesome power that
Yeah.
Asya's talking
Yeah.
about, right?
Yep. So you get to say aggregate, which is, it's just a helper that all of the drivers provide
Mm-hmm.
that then turns it internally via the wire protocol into the aggregate command, which takes, the collection name and then a pipeline. And then the pipeline is the pipeline of stages, plus some options. And the
Mm-hmm.
pipeline of stages is where you get to express what you want. Uh, Here's an example. Instead of saying find one, you can say find and then limit one explicitly, or you could say aggregate dollar match and then your exact find query, right? Your entire
Mm-hmm.
find predicate, and then you could say limit one,
Mm-hmm.
and then you could say project and then whatever was in your projection for find. And it turns out that under the hood, at least if you're in the latest version, it's actually going to use the exact same code path as find, and find one is the exact same code path as find, just with the special limit one semantic. So what we're working on doing is separating the language from the execution. So if you have multiple ways of expressing the same thing in the language, they should execute the exact same way,
Mm-hmm.
right? And that's exactly kind of what we're doing in terms of merging the two. In a future version, for example, the projection in find and the projection in aggregation are merged into the same code. Same for sort in find and sort in aggregation, right? So that's going to reduce kind of the number of places where we have to maintain multiple code to enhance things. Plus, we never want to have different behavior when you do something that appears the same. If you do it differently, we want the behavior to be the same. And the easiest way to make sure of that is if there's only a single code path through the execution engine.
Well, that's great. So it all boils down to the same execution under the covers. Is there a performance enhancement, whether you use one way, whether it be find or an aggregate command?
So in the past, if you went through aggregate, it would be slower than an equivalent find, but we fixed that. And like I said, having it take the same code path means it's going to be identical and you wouldn't be able to tell the difference between the two by, for example, looking at performance or an explain or something like that. Now, there are things that you can't do in find that you can only do in aggregation. And depending on how complex they are, of course, they would be slower than just a simple find. So aggregation is kind of interesting because for some things, it certainly can be used, as kind of OLTP-ish live queries, right? If you're using it for some, limited number of documents, very efficient transformation, it's still going to run in, milliseconds, just like most of your queries would. But if you're analyzing a large data set, usually that's more of an OLAP type query, right? The analytical processing type queries, and those are sometimes not going to be in the kind of latency that a customer who's sitting there and clicking on a button somewhere on the website would expect. They might be okay if it's a button on a reporting thing somewhere, right? So there are complex aggregations and simple aggregations should always run really fast. But long and large complex ones will generally be slower because, well, nothing is free. If you're doing a lot more work, right, it's going to take longer.
So in the simple example that you just gave with the find one and the limit being comparable to the aggregation framework, is this a scenario where maybe you wouldn't want to use the aggregation framework and you should just stick to one of these helper functions like the find and find one, or maybe give some opinion around that?
I don't think it matters, right? So I know a few places where at one point they decided that they wanted across their whole code base only use aggregate for any kind of queries, right? I'm not sure if it was just simpler for them, right? Because
Sure.
maybe, they had some layer where they just didn't want to have to worry about sending it more than one type of command, right? And that's why we wanted, no matter how you format a particular operation, if it can execute along the fastest code path, it should go along that fastest code path. So I don't have a strong opinion about this, especially since, going forward, I think that there will be more overlap. I think, my general philosophy about existing things is if it ain't broke, don't fix it.
Sure.
And my philosophy about new things is, do what seems simplest and most straightforward, right?
Yeah, sounds good. So now what I want you to do is I want you to take us on a journey right now. So a storytelling journey. I want you to think of a complex aggregation scenario that really kind of showcases the power that you would receive out of using a pipeline. So what could users do that's like, wow, this is amazing stuff. You got
Okay,
got anything in your
I do.
in your mind on that?
I do. I actually tend to always use the example that was the last example I broke down in my original aggregation pipeline power talk in like 2017, 2018. The reason I use it is it was something that, the request for it came from a customer, an actual user. It was something that didn't seem intuitive that you would be able to do given the very, superficial high level knowledge of the pipeline. And I liked it because after, taking just a few minutes to walk through building it, people who had never seen aggregation pipeline at the top of the hour would genuinely feel like they followed it. Now, it's because I'd break down the operators and expressions that we used in that pipeline, in the previous portion of the class. But the general problem was like this. The customer had, let's just call them like set-top boxes, right? I don't actually even remember what exactly they did. Maybe it was, streaming service, maybe it was gaming, maybe it was something else. But, there was a box that you had on top of your whatever, TV or network router, and you get to log into it with your username. Now, they wanted to analyze a collection where they had every single login by every single username over time. And they wanted to be able to, for a particular time period, so let's say for the last 3 months or a particular window, 6 months at the beginning of this year, they wanted to find all of the users who logged in within a 10-minute period from 2 different IP addresses. Now, I'm speculating here, but I'm thinking they may have thought, well, maybe people are sharing their login, their username and password with people who live somewhere else and essentially kind of gaming their subscription system, right? So you go, well, clearly there's no simple query that will give you, all the usernames, but given that you have usernames, timestamp, and IP address from which they logged in, what we did was we, stage by stage, built a pipeline that at the end output the users, the 2 different IP addresses, and the duration, the time difference between, that first login into one IP and the second login from the other IP. And if I were to describe it stage by stage, obviously the first thing we did is match where the timestamp is in that 3 months, 6 months, whatever window they were interested in analyzing. And then we would sort by user ID, timestamp. So now all the users are next to each other, but within each user, there is a particular order to the timestamps, oldest to newest. So then we did a group grouping by username and pushing onto an array in the oldest to newest order, essentially subdocuments containing time and IP address. We also, in that same stage, would do an add to set of the IP address. And this is so that in the next step, if over the 3 months they only ever logged in from a single IP, we could just filter them out. So we had another match after the group saying, if they only have one IP address in that unique IP addresses from which they logged in, then filter them out. Everybody else had more than one different IP address. So then in a single stage, we'd iterate for every user over this ordered array. And if you think about it as code, which essentially what aggregation stages let you write, is, you have an index that goes from 1 to, size of the array -1. And, you compare the 0th element to the first element. And if the IP addresses are different, then you subtract the older time from the newer time to get essentially the time window during which that happened. And you just iterate over the array like this. And then you filter out. What I did in that one is, if the IP address was the same, I gave the time delta a large value, like 999, right? Otherwise, I computed the difference in minutes. And then there's a filter that eliminates from this array all the elements where the time difference is greater than 10 minutes. So what that leaves you is, less than 10 minutes. And then in that same cycle where you eliminate the entries, is you also eliminate ones where IP1 is equal to IP2. So what you're left with is users either with empty arrays, which you can filter out in the next stage. And what that leaves you is with users who have in their arrays a subdocument that says, between this timestamp and this timestamp, which was, let's say, 4.5 minutes, they logged in from these two different IP addresses. Wow, sounds
That
really
is a complex query. Yeah. It's probably a lot less complex than it sounds, right? When you start writing it out.
Yep. It's like match, sort group, then
Yeah.
match, then a project to generate, to compute those deltas, and then another match, and that's it. And what you're left with are the people who...
It's a very linear process, right?
Yeah, kind of.
So then I guess the next question I have, because there's a lot going on in that process, of course, is how do you keep it performant? Do you have to worry about creating special aggregation indexes or do anything special?
No, that's the cool thing is indexes help you with selection of a subset of documents from your collection, right? Because an index is a special data structure in which we can very quickly look up particular values of the fields that are indexed, right? Indexes can't help you with faster computation in memory, for example, right? So only really the first parts of the pipeline that pull the documents through a cursor from our storage engine are the ones that can be, accelerated. So I sometimes tell people, here I wrote something using, 3 separate stages, and I could combine them into one. But I'm more worried about correctness first, readability second, and relatively small performance improvements last. So, if you don't have an index, that's going to might take you 100 times as long as if you do have an index, just to pick out the subset of documents that match your desired pipeline or query.
Mm-hmm.
But, reducing 2 subsequent stages into one, it's going to be so negligible by comparison that I always tell people, just, worry about correctness first and readability second. And you're not going to be able to get really huge improvements, from being tricky and combining something really tightly. However, when I initially work out this pipeline, I just, pushed all of the pairs, of times and IPs into an array, and then had this big iteration over it in the next stage. But then I realized that group already has the ability to accumulate unique IPs. And if it's the case that majority of the users only ever log in from one IP address, then adding an extra stage and extra work to the group to filter out those documents actually reduces significantly the amount of work that later stages have to do. So what I say is, don't worry about the efficiencies of like individual stages. Worry about reducing the number of documents that flow through the pipeline as quickly as possible.
Right. So move that match to the earliest possible point in the set of stages.
if you can. Exactly.
Right. Yeah, I was going to ask about general guidance for good practice. Like what best practices are there for developing your ag pipelines, if you have any suggestions? And then I'm also interested in the process. Like, how do you write these massively complex pipelines? I mean, where do you begin to do this? Do you use Notepad, Visual Studio? What do you use to develop these things?
Well, I mean, I would say Compass for somebody who's relatively new to it, right? But once you're a power user, it helps only as an IDE, for matching parens. But I frequently just do it in the Mongo shell because Mongo shell will show you where your closed parens don't match. You know how like if your cursor is over closing paren, it'll highlight the opening paren. Right, because that's really one of the most frustrating thing about writing a complex JavaScript thingy-majiggy.
Mm-hmm.
But also, when I'm in the shell, you can set up via editor variable, environment variable,
Mm-hmm.
and you can edit any line that's on your shell, and that'll just throw you into the editor where you can use your favorite, plugins and tricks to edit things. And when it's done, you save it, and it'll take you back to the shell to run it. This is where a screen share podcast would be so much easier to show than explain, but maybe I'll write it up in some blog post or something we can link from this. So, and then conceptually, as far as how I write it, it's just like writing code, right? You think about what you need. I go, okay, what subset of documents do I need? Okay, how do I need to group them? And then kind of go stage by stage, and then I have a result. Ta-da!
So just for clarity on a lot of things. So, I mean, a lot of these listeners for this particular podcast, they're going to be new to the whole subject. The aggregation pipeline, are we looking at this for read-only operations? Can we do any kind of operations that kind of pipes data back into the database after we do a manipulation?
Absolutely. So since about, I think 2.6, which was, I'd say about forever ago, to 2015, maybe 14, I can't remember. Anyway, since back then, we had the ability to have the last stage be $out. And $out will write, instead of returning the results back to the client, it will write them into a collection. Now, it had some limitations because you could only create a new collection and that collection couldn't be sharded. So much, much more recently, we added a different stage that you can have at the end called $merge. And $merge will write out the documents that are at the end of the pipeline into an existing collection. And you have a bunch of options. You can specify what to do on match, and you can say how to match up documents. Like by default, it'll be like _ID or _ID plus shard key, but you could specify a different field that's a unique identifier and say, okay, the way I want to merge these is, overwrite, these fields and then add these two fields together, or et cetera, et cetera. You can also specify what should happen when there isn't a match, like insert or discard or something. So the aggregation command itself can output data into an existing collection. But also you can use aggregation in other places. So for example, in 4.2, we've enabled you to express your update as a series of aggregation stages that mutate the document. So just like, $set in the traditional update was just set this field to this value. Instead, you could say set this field to a sum of this other field plus a value times some other field, or conditionals, or anything that you could do within an aggregation expression. And then that would be the update, essentially starting out with the document the way it was at the beginning of the update, at the end of that transformation pipeline on that individual document. That's the document we would persist. But that's part of the update command now. It's not part of aggregate.
In the example of update, being able to do aggregation, that's optional, right? You can still use update as you would in previous versions.
Yeah, in fact, the syntax to indicate that you're using aggregation is to provide an array in place of a mutation document. So previously, if you tried to provide an array in an older version, it would just give you an error and say, I'm not expecting an array here. I'm expecting a document that says, like, don't set this, also, right? But when it finds an array and it's the newer version that recognizes it, it'll be like, aha, that's an aggregation pipeline syntax. and will know that it's now taking the existing document and applying the transformation that you specify in the pipeline to it. Obviously, it's not the entire pipeline. You're limited to a subset of stages that mutate a single document.
Got it. So are there any kind of words of wisdom or any kind of ideas or just anything you'd like to share with the listeners that we might have missed on this particular episode regarding aggregation?
Well, that's a really open-ended question.
Yep.
I actually asked, a bunch of my colleagues and folks on Twitter what they most wanted to know, and it was mostly stuff like, "Oh, how do I break down large aggregations, and when is the book on aggregations coming out?" So, I think the key thing to remember is it's very powerful syntax, but just like any other programming language, to get the benefit from it, you have to learn the syntax, right? So people sometimes are frustrated and they're like, well, I just looked at the docs and I couldn't figure out how to do it from like the one try. I go, well, would you feel the same way about a program, right? If I'm trying to write something in the programming language I don't know, I'll usually go and take a fairly complex example, paste it in, try to compile it and run it, whatever. And if it runs, then I kind of try to figure out which parts of it I can tackle changing based on my limited understanding of the syntax. But to be able to write really complex pipeline from scratch is just like writing any program from scratch. It just becomes much easier with time and experience.
Awesome. Well, I want to also give you an opportunity to plug anything that you're working on. So you mentioned a book. Are you writing this book on aggregation?
I want
No?
to, but there's no time. Also, things change so fast. Books in the traditional paper sense are just, it's kind of hard to imagine it being relevant more than maybe a year at a time at most.
Yeah.
Online books obviously, or ebooks, are obviously better in that they can be updated and iterated over much faster. I think that so many of us learn not by sitting down to a book and reading it end to end, but just by going through lots and lots of examples. And so I just try to write examples. I have a blog I call Stupid MongoDB Tricks, where sometimes, and the reason it was called that is, as I was frustrated very early on that there wasn't advanced functionality to do X or Y or Z, I would write kind of like I called it a hack for it. But it was the only way to do something at the time in the limited syntax. And as we added more expressions, the hacks had to get much more clever or much more stupid, as they say. It's a fine line between
Yeah.
the two. So yeah, and I'm very active in all the MongoDB communities and the new community forums. So I love to hear what people are struggling with and why, because I kind of feel like from a product perspective, we can always make things better. And when I gave a talk, an extended version of this talk, I think it was in a London event a couple of years ago, somebody asked me at the end, because I said, we're always trying to improve performance of the pipeline and the database in general. And they said, well, when will you be done making performance improvements to the pipeline? And I said, when I don't have to give talks to tell you how to make your pipeline run faster.
Yeah.
Right? As long as it's correct, if we can figure out how to rearrange things to make it as optimal as possible for execution, I don't want people to be thinking about how do I write this in a way that's more efficient, just like we expect compilers, right, to rearrange the code in a most efficient way. I want our execution engine to worry about that. But we're not quite there yet. So, put your matches as early as possible.
So, I mean, in regards to getting more help, do you happen to know if there's an aggregation lesson on the MongoDB University?
Oh, yeah, there is. It's MongoDB University. Our docs have it. There are recorded talks. For example, I know for a fact we have at least one, if not both, of the talks I've given on aggregation pipeline, somewhere on the site. Luckily, I have a unique name, so searching for it hopefully should be pretty easy. And then the aggregation class, I don't know, either one of you guys remember, is it like 220? I can't remember what number it is, so I can't say offhand, but it's actually called like aggregation pipeline or aggregation framework. If you go
Sure.
to university and you search through the classes, you'll find it.
We'll see if we can add it to the show notes after the
Yeah,
episode.
that'd be great. I'm also hoping that we'll do a more advanced class maybe, so that
Yeah.
people don't have to look for an old talk of mine, but instead can, take it in as part of their regular university stuff. And also, if none of those things answer someone's question, come to communities mongodb.com site, there's some forum about working with data, tag it Aggregation Framework as a tag, and we'll all see it and hopefully get you the right answers.
Awesome. Well, we appreciate that you took the time out of your very busy day, Asya, to be on this podcast episode. I have a feeling that our listeners are going to learn quite a bit from it.
Yeah, my pleasure. We can always do a follow-up if there are follow-up questions. And
Yeah, definitely.
yeah, maybe next time we can figure out how to get video.
Maybe, yeah. All right, thanks.
All righty. Thanks a lot. Bye-bye.
Thanks for tuning into this episode of the podcast. If you enjoyed what you heard, it would mean a lot to us if you went into Apple Podcasts or some similar network that you're listening to it from and left it a 5-star rating and review. Maybe said something nice about the show itself, so that way you can give future listeners a kind of an idea of what they're getting themselves into. If you have any suggestions that you would like to leave us, you can find us on social media, or you could join our community at community.mongodb.com. We hope to see you on a future episode.